We move on to question 8. Question 8 reads as follows. The odd digits 1, 3, 5, 7, 9 are constructed of matchsticks as shown below. Well, you can see the picture there. Using each digit only once, how many 3-digit numbers are there that have the sum of their digits greater than the number of matchsticks used to make the number? Now that's quite a mouthful. Um, the question refers to the number of matchsticks that are used to make that number. So let's just see how many matchsticks there are to make each number. There are 5. Okay, so there are 5 numbers, and each number has got a certain number of matchsticks. So what I'm going to do is count the number of matchsticks for each of these numbers. So I'm going to write down these 5 numbers, count how many matchsticks there are for each number. Sorry, I didn't divide it up equally. So the 1, the 3, 5, 7, 9, and the number of matchsticks for each of these, to construct each of these numbers. For 1, it's only 1. Oh, it looks like 2. Yeah, there are 2 there. All the matchsticks of this got the same length. So you got 1, 2, 3, 4, 5. For 5, you got the horizontal is 3 and the vertical is 2. So there's 5 here also. And here the horizontal is 1 and the vertical is 2. That's 3. And here the horizontals are 3 and there are 3 verticals. So this makes 6. So this is the number of matchsticks that is required to make each number. All right. Now, you say how many 3-digit numbers are there? So you're going to make 3-digit numbers out of these, right? So we list down all the number of 3-digit, all the 3-digit numbers that can be made, and I've got them here. See, this is the group. So if I took 135, that's one 3-digit number. Of course, there are, okay, one 3-digit number. I'm just going to count the groups. I'll explain that just now. So 135, I'm not going to use these 3 letters again. Then I go to 137, 139. So you take 1 and 3 as the first 2, right? And then you got these 3. Now you can take 1 and 3 as the first 2, but now you go to, no, you finish the 1 and 3 as the first 2. So now you go to 1, 5, right? And then you can have 157 or 159. That's for the 1, 5. And you can go to 1, 7. So that takes care of all the ones. So we finish with that. So we can start with 3 now. So you can go 3, 3, 5, 7. Starting with 3, 3, 5, 9. That finishes the 3, 5. So you can go to now 5, 7. 5, 7, 9. Right. Now, let's just count how many matchsticks are used in each of these numbers. For 1, 3, 5, okay, they say that the sum of the digits is greater than the number of matchsticks used. So let's work out the sum of the digits. And these are the sum of the digits which were calculated. And the number of matchsticks used for 135 is 2 plus 5 plus 5, that's 12. Okay. And in the same way for 137, the number of matchsticks used will be 2 plus 5 plus 3, and that makes 10. See, like that, we worked out the number of matchsticks used for each number, and we worked out the sum of the digits of each of these numbers. And the question is, the question is, using each of these, how many of these numbers have the sum of the digits greater than the number of matchsticks used? So the sum must be greater. Now, here you can see the sum is greater. 11 is greater than 10, but this is doesn't qualify. These are equal. So here, this is greater, this is greater, this is greater, this is greater, 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 greater. I've got all those in bold here. All right. So if you work it out, you see that you've got 3, 6. So there are eight cases where the number of matchsticks is greater. So the answer is 8. All right. 3, 1, 2, 3, 4, 5, 6, 7, 8. Yeah. So there are 8 cases where the sum is greater. So the answer is 8. So let's just check to see whether this is indeed the answer. Oh, the answer is not 8. All right. The reason for that is, let's just go back to this. You see, I took 135, but each of these can be, there are 6 possibilities to mix these around. You could have had 153, or you could have had 5, or 315, or 351, or 531, or 513. There are 6 ways of arranging these numbers, right? 135, 153, 315, 351, and 531, 513, 531. So, and all of them give you the same sum and the same number of matchsticks. So, each one can be counted 6 times. This one here can be counted 6 times. So, the final answer is, although there are 8 groups, but each number can be counted 6 times. So that's how you get 48. Okay, so just as well, I had a check here. Okay, so that takes care of, let me just expose this one. So you can see the answer is 48, it says. All right, we get on to the next problem. Question 9. A rain gauge is made up of 2 cylindrical shaped funnels. So you can see this is a single rain gauge. 16 millimeters of rain falls into the funnel with diameter x. So the rain is falling down here, let's say, and this funnel has got diameter x. So the is x. And how many meters? 16 millimeters of rain falls into this funnel. So the height of the rain so the water is like that. And let's say the height is h. Okay. Now, and this water drains into another funnel. So there's your second funnel. It drains into this. And this thing has got diameter 4, right? And the height of the second funnel is 4,9. Right? And this water drains into this. So I think it should have said that it drains it and fills it up. So all this water drains and fills this thing up now. So the water goes right to the top. Okay. So the question is now, what is the value of X? What is the diameter of this top funnel? The important thing here to remember is that the total amount of water, the volume of the water, is the same as the volume, it fills it up. So it's the same as the volume of the cylinder. Now, the volume of the water is a cylinder. What is the volume of the cylinder? Let's just write down that formula. The volume of cylinder is pi r squared times h. The area of the base times the height. Well, let's not put h here, let's put height. I already got h here. So this is 16 millimeters. So I should have put 16 here. Right. So that's the height of that. That's 16 millimeters. All right. So the volume of the water here is pi times, this is a cylinder, and its radius is, the diameter is x. So the radius is x over 2. We're talking about the water here now. So the radius of that is x over 2. So that's pi. You square that, multiplied by the height, which is 16. So this volume is the same as the volume here, which is, again, the same formula, pi. Now the radius of the base is 2, because the diameter is 4. Pi r squared, and the height is 4.9. Or you had 16 millimeters of rain. And here you've got 4 centimeters. So one has to be a little bit careful, because you must get the same dimension. So this is, we better work in centimeters. So this should be 1.6. That's 1.6 centimeters. So everything is now in centimeters. 16 millimeters is the same as, you have to divide it by 10, 1,6. So this is your equation. There's one unknown. We can cancel the pi's, and let's do this. You got x squared over 4. So it's 1,6 times x squared over 4 equals 2 squared is 4. 4 times 19. 4 times 4.9, sorry. Okay, so therefore x squared is equal to 4 times 4,9 times 4 again, divided by 1,6. Okay, so that's your x squared, making that x squared the subject. I can move the decimal places here to get, this is 4 squared times 7 squared. This is 49. And here, I can move the decimal place here to get 49 over 16. In other words, I multiply the top by 10, multiply the bottom by 10. Now I got all squares, you see. So I got 7 squared, and this is 4 squared, and 4 times 4 is 4 squared. So this is x squared. If you cancel this, you got x squared is equal to 7 squared. So therefore, x is equal to 7. All right. And that will have to be 7 centimeters, because we converted everything into centimeters, including the 1.6 millimeters of rain. All right. So that is the answer that we get bearing in mind that the volume of the water here is the same as the volume of the cylinder because it fills it up. Okay, let's just check to see whether our answer is indeed 7. And if we go down to the answer here, there we go. So X is 7. All right, so let's just get on to the next problem. Okay, the next problem seems to be a geometry problem. Okay, the numbers 2, 6, and 7 on the face of a clock. So there's 2, 6, and 7 are joined, okay, to make a triangle, as you can see. Calculate the size of the angle X. That's quite an interesting problem. Okay. So to calculate this, these 3 points are sitting on a circle, and we better exploit that fact. The circle's got a certain center, so we've written O as a center. Okay, so I need to calculate this angle here. Now, as it stands, if to calculate this angle, I have to use the fact that the center of the circle is equidistant from the 3 points on the clock, right? Because this is a circle, the radius will be the same. So let's just draw those lines, and I've drawn those lines here, those 3 radii, like this. And now we need to calculate this angle here. But the nice thing about this is that here you got isosceles triangle, you see, because these 2 red lines make an isosceles triangle, these 2 red lines make an isosceles triangle, and that allows you to calculate some of the angles. But are there any angles that you do know? Well, look, this distance here, when you join this is quite important. The distance here is just 1. I could have, this angle here, if you call it X, or let's call it Y. If I join it to, I could have joined it to 8, could have joined it to 9, could have joined it to 10. And all these angles would be the same because it's from 6 to 7, 7 to 8, 8 to 9. So all these angles are the same, all these Y's. So that how many, if I go right round, I will have the 12Y equals 360 degrees. Right? If I go right round, because there are 12 such separations on a clock. Number of 5 minutes, these are 5 minutes, in 60 minutes is 12. So therefore, the Y that we've got there is actually 30 degrees. So this angle here is 30 degrees. Let me just wipe all these things out to make it a little bit easier. So what we've done here is seen that this is 30 degrees. Now I'm trying to get to this angle here. Now this 30 degrees, if you look at this triangle, this is isosceles here. So this is 30, so the remaining 2 angles, I'm talking about that angle and that angle, those 2 angles will add up to 150 degrees. So this angle here, they're both equal. So that angle is 75 degrees. From the red line to the baseline, that angle is 75 degrees. Now, let's try to calculate this other angle here. Call it dot. Then if you can calculate dot, then the X will be 75 plus dot, right? So we are nearly there. We've broken the X into 2 parts. We calculated one, we need to calculate the other. Now in this case here, you've got, if I did the same thing that I did before, from break this angle up into there and join this and join that. Now you got, we saw that each of these is 30 degrees. So this is 30, 30, 30, 30. There are four 30s here, which make up the angle between these two red lines. All right? So the angle between these two red lines is four 30s. Because there are 1, 2, 3, 4. So this is 120 degrees. And these two are the same because they are radii of a circle. So you've got an isosceles triangle. And this dot here, these two dots, together with 120, gives you 180. That's the sum of the angles of a triangle. So those two dots, they add up to 60 degrees. Both of them are equal, so each one is 30. So the dot is 30. So the angle that we're looking for, this x here, is 75 plus 30. And that is 105 degrees. Okay, it's a nice problem. So it's a nice fact also that each, that the angle, but that you use the word subtended, that this line here from two consecutive numbers, if you join it to the center, that new angle is 30 degrees. So that's a useful fact to remember about clocks. Okay, so let's just check to see whether our answer is 105. And if I clear out all these drawings, yes, we do have 105 degrees, so that checks. So let's now get on to the next problem. We go to question 11. There are 15 questions in the third round paper. The second round, there are 25 questions, but in the third round, juniors, there are 15 questions. So you still got 5 more to go. Okay, so you've got, find a 5-digit number, A, B, C, D, E, with no repeated digits. All right, so you've got, this is a 5-digit number. It's given that the last digit is 1, and that is equal to 3 times, the same 5-digit number is now on the other side. Okay, so this is a single 5-digit number. We can say this is like n. If n is a 5-digit number, A, B, C, D, E, this is not a product. N could be, like for example, n is equal to 39147, for instance, right? They say no repeated digits. So if n is this, then you got that the 6-digit number n1 is equal to 3 times 1 n. Now this is also a 6-digit number. Now this thing here is really 10n plus 1, because the 1 is the units digit, and like this one here, for instance, is the n1 is the same as n0 plus 1. So 0 plus 1 is 1, and the whole n comes down. Okay, so n0 means you're multiplying n by 10. You're putting a 0 at the end. So that is why you got 10n plus 1 here. And this is equal to, it's equal to 3 times now here, the 1n, if I put 1 in front, and it gives 39147. This is really 1 with 5 zeros plus 39417 or 147, right? So this one here has got a different meaning altogether, this one here, right? It's actually 10,000. So this is 10,000 plus n. Because, yeah, as we can see in this diagram, in this explanation, you can see it quite clearly. Because this is the sum of two numbers, but one of them is 100,000. Right? Actually, you got 5 zeros. Okay, so that gives you an equation in n. So let's bring all the n's to one side. 10n minus 3n is equal to 300,000 minus 1. Bring the 1 to the other side. And here you have 7n equals to 2. Okay, when you take out, oh, you have 2, I don't know how many nines you've got. I think it's 300,000. So you have 299,989. That's 7n. So you have to divide this by 7. And you see this thing goes exactly. 7 goes exactly into this. So your number n is this number. That's the answer. So I solved this problem by just putting a single symbol for A, B, C, D, so that becomes a single unknown, one unknown, rather than 5 unknowns. Okay? And that helped me a great deal. And I wrote this equation down in terms of n and got the answer. So, all right, so that is the answer is 42857. And just remember that, because when we go on to, so there it is. Okay, so we call it X here, so it's 4,000. Yeah, this is exactly the same answer. Okay, so let's get to the next problem. Question 12. In the following alphametric puzzle, okay, you see these kinds of things where you got symbols, letters of the alphabet, and there's some calculation which is being done, and you're asked to find out what these digits are. So in this particular problem, you got a 6-digit number, TikTok, plus itself is equal to install. That's an interesting alphametric because it actually tells a story. So install TikTok. But what are these letters here which make the sum? There's a plus sign here, which makes that. All right, I've got several diagrams here because I'm going to try various things. So you have to try out various things and try to use logic to calculate this. Well, let's for a start now. This thing here has to be 1 because when you add two single digits, the worst case is 1. You can't have 2 or more because two single digits cannot be more than 20. So the I is 1. So I'm going to put a 1 here. That's I is occupied in the third place. So there's a 1. There's a 1. Now don't write down 2 here. It could very well be 3 if I'm carrying over something. All right, so that takes care of that. Now here you've got k plus k. So this is an even number here because it's k added to itself. So L could be any one of 2 or 4 or 6 or 8 or even 0. But yeah, but 0 means you could have had 5 and 5. Okay. So Let's just take some cases and try to see how you work with this. I'm not going to do all this. It takes a long time. So suppose L is 2. So you'll put L occurs here as well. All right. So now this to get the same number added to itself with the 2 here, it could be 1 plus 1, but 1 is already taken. So all these digits are must be different. So the other way you can get this is by 6. So you get 6 and 6 is 12, right? And then you're carrying 1. Now, when you carry 1 and you're adding it to O plus O, O plus O is even. When you add 1 to an even number, you can't get 2. 2 is 1 plus an even number is an odd number. So you can put nothing here, because when you're carrying 1 and you add it to a double of a number, you can't get it. So this 2 is wrong. So let's just eliminate the 2. So let's try. I've got more pictures here, so let's try 4. And remember, we still got 1 here. You got 1 here, you got 1 here. Okay, in this case, I could have had 2 plus 2. Now you can't have 7 plus 7, you see, for the same reason, because when you're carrying 1, so this has to be 2 plus 2. Because when you're carrying 1, 1 plus an even number would be an odd number. So this is 4 here. So this can't be 7. Okay, let's put 2 plus 2. So the k is now 2. So you got TIK. So there's a 2 here, and there's a 2 there. Right? Okay. So here you got 4. So this has to be 7. 7 plus 7 is 14. You're carrying 1. But the O is 7. So you're carrying 1. And you got yeah, so we don't know what this T is. But observe that this thing here is the same as these two. All right, so you can try out different numbers here, right? And try to see whether these, whatever number you put here must come in here as well, right? Now, 2 plus 2 is 4, but the 4 is already taken. So this will have to be 5 here, right? So this has to be 5. So we're carrying 1 over from this side. But this 5 here is the same as, this is your T. So this is 5. So you got 7 plus 7 is 14, carry 1. 1 plus 10 is 11. Oh, you see, so this becomes 1 here, and that's not allowed. Right? Now, let me just go over this. 2 plus 2 is either 4 or 5. It can't be 4 because it's already taken here. Right? So it has to be 5. But once you got this T is 5, you can put those in, and you can calculate this. 7 plus 7 is 14. You carry 1, and you will have to have 1 plus 10 is 11. So there's a 1 here, and that's wrong. So 4 is out. So let's try 6. This has to be 3. And you've got a 1 here. You've got a 1 here. 1, 1. And this has to be 8. 8 plus 8 is 16. Right? And we still have the 2 and 2 is 5 here. Oh, no. This could be 4. This could be 4. 4 is not taken. So it's 4 or 5. So you get 8 plus 8 is 16. You carry 1. Now, 8 plus 8 is 16. 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 8 Now you carry 1, and so when you add these 2, you're going to get an odd number here. Carry 1, and these 1 plus, so this is going to be an odd number. Right? So you can try out 4, and you can try out 5. Okay. If I try 4, 3 plus 3 is 6, 8 plus 8 is 16. I have a 9 here. Ah, but now, yeah, this is 4. That's fine. That's 4. And then you get 1 plus 1 is 2. Uh-oh. This 2 is now repeated. But that's supposed to be n. So that doesn't work. Right? So this 4 is wrong. I chose 4 or 5. So this has to be 5. 8 plus 8 is 16. This has to be 5. This is 2, 2, 5. 8 plus 8 is 16. 1 plus. Hmm. 16. So this is 1. So even this doesn't work. Okay. I seem to have got uh, lost here somewhere. Hmm. Okay, let me see what the answer is. Okay, you can keep trying it out. I don't want to waste your time. But the final answer is the following. Oh, there it is. I got 8 plus 8 is 16. Oh, this is not 2, man. I don't know why I put 2 here. I carried that 2 from there. I made this thing 2 all the time. When I put 3 here, these numbers become different. Okay, so that was the problem. There was no 2 here. This is certainly 1, 1. And this each time you put a number here, you have to put the same number here, you see. So you go tick tock. The K's are repeated. I kept putting 2 here. When K is 3, I'm supposed to have 3 here. So K is 3 here. I'm supposed to have 3 here. And that 3 plus 3 gives you, can't be 6. It has to be 7. And if that is 7, then those 2 are 7, you see. And then you see that this is the thing that works. All right. Sorry, it involves trial and error. You can see you can make errors as you go along. The logic is very fine. Let's get on to the next problem, which is question 13. So in a square, the diagonals are drawn. So this is a square here. Okay. So in a square, you got the diagonals, and just remember now, all the sides are equal, all the angles are 90 degrees, and these diagonals are equal in length, and you've got 4 triangles, all of them, the angles are 45, 45, 90. Those are the properties of a square. Okay. Now you've got a midpoint here. You can see it's drawn like that, and this is joined. Now determine the ratio of the shaded area to the total square. So you needed to work out the ratio of this shaded area. All right, now look, this is not an easy problem, and it took me a while to get to the answer. But I found that you can get to the answer by drawing a new line here, from here. You see, I don't know what this division is. I can work out the height. The height of this triangle, there's 90 degrees here. The diagonal of a square intersects at 90 degrees. So I can calculate the area very quickly. They're saying it's half base times height, but I don't know what this base is. All right. Okay, so let's just give some names to this thing. Let's call this. Let's call this one here A. Let's call that A. And so this height here is B. So you needed to work out half AB and know what the area of the entire triangle, the square is, because you need to work out the ratio of the shaded area to the whole area. So let's see whether we can get everything in terms of A here. And to do that, you perform a little construction. That construction is, I draw a line parallel to the diagonal. So these are parallel. And when I do that, I can use the midpoint theorem, you see, because the midpoint theorem says that if you draw a line parallel from the midpoint of a side, this is a midpoint theorem. Whenever you've got a triangle and you got the midpoint of one of the sides, if you draw it parallel, these are equal and this is parallel, then these now become equal. The conclusion is that these two become equal. In fact, there is a more general result which says the following. I can still take a triangle, but I don't have to take the midpoint. I can take, let me use black. So I can have a triangle. If I don't take the midpoint, if I take like that, then the result says, the theorem says that the ratio of this part to this part is the same as the ratio of this part to this part. Right? In other words, those two fractions are the same. Like for instance, if I had, suppose I had, this is 3, and this is 5, and this is 6, then it means now, well, sorry, the scale is not right, but so this looks like more like 5 and this looks like 3. Let's do that. I don't like. So if you had these sides of 5 and 3, for instance, 5 and 3, and if this was 10, then this will have to be 6. Because 10, the ratio from this to this is the same as this. So this has to be 6. You can conclude that. See? We're going to use that as well. So it's an important fact. Okay, so what do we have here? These two are equal. So these two are equal from this midpoint theorem. So let's call these two, let's call them B. All right. The midpoint theorem also says that if this length is L, then this part here is 2L. That this join of these two is half this. See? In fact, the ratios of all, you see, this small triangle is the same as this large triangle. If this is parallel, they've got the same angle, you see. So these two triangles is just a miniature version, the small triangle, the miniature version of the large triangle. So the sides will be in proportion, you know, because each one is being multiplied by the same amount, and even this will be, if this was 7, then this will have to be 14. See, the sides are in the same ratio. Okay, so if you get back to this now, so this means if this is B and B, so this part here is 2B, and it's the same as this. Because in a square, all these are equal. All these are 45, you see. So if this is equal to 2B as well, and this will be 2B. So now you see, I've got this upside down triangle, which is very similar to this, because you've got 2B is B. So the ratio of, now I can calculate this one here. How is that so? Because I've got the large triangle, the ratio of 2B to the large triangle is 2B over 3B. This over this side in the large triangle will be the same as this over that one. Right? Because this is the side of the small triangle, that is the side of the large triangle. So 2B over the large one. Just like this, 5 over 8, 7 over 21, and so on. Now, this is not 14, but sorry. So you got 5, 10, 7. And yeah, you got 8, 16. Yeah. So the multiplying factor is uh, 8 over 5. See, this, the whole thing is 8. This is 5. So this line here is 8 over 5 times 7. So this will be 8 over 5 times 7. Okay, so that's why I've got here now 2B over the whole thing is that. So the B's cancel. So the question mark is 3A over 2. Right? 2 times the question mark is 3A. So this is 3A over 2. All right. Yeah, but now this line here is half this entire line here. Okay, so from that midpoint theorem. So this entire line will now be 3A, because this is, if this is 3A over 2, this has to be double. So the entire line is 3A. So now that at least tells me that this has to be 2A. It's quite a difficult problem. So this is 2A. Now, so you've got everything in terms of A now. So if I, so this from here to here is, so 2A is equal to 2B. So A is actually equal to A, because this length is the same as this. So 2A is equal to 2B. A is equal to B. So these now become, actually, I'm sorry, it's 3A equals 2B. 3A equals 2B. All right. Okay, let's just keep this because this will be useful. So now we know the area. The shaded area is what? Half base times height, and that is AB. And what is the area of the square? So this is 2B. All these lengths are the same. So the area of the square is this side squared is S squared, but this is by Pythagoras, S squared is 2B squared plus 2B squared, which is 8B squared, right? And AB, we said that B is 3A over 2. B is 3A over 2. So this is A times 3A over 2. So now you have the shaded area in terms of A, and maybe we'd better put B is A is 2B over 3. Sorry. I've got this side of the square in terms of B. So I want to work out the area of the triangle in terms of B. I already have a B here, but the A, I can replace it with B by looking at this. Because A is 2B over 3. So the shaded area, the ratio that you're looking for is a shaded area, which is 2B squared over 3. That's what we got here. All over 8B squared. The B squareds cancel off, and you have 2/3 over 8, and that gives you 1/12. So the ratio of the shaded area to the total area is 1/12. Hard problem. But uh, we needed the midpoint theorem, which you might not be familiar with, and you also needed this result that if you've got two triangles which have got the same angles, then the ratios of the sides are the same. That's what I've used. This over this is equal to that over that equal to that over that. That I've used in this case here, because this true triangle, this shaded triangle, has got the same angles as the large triangle. So you could do that. Okay, so that takes care of that problem. The answer is 1/12. And you can see here at the end of this, I've got 1/12. And it's exactly the same diagram of construction that I used, which took me a long time to come to. All right, so let's just get on to the next problem. And we go to question 14. Question 14 says, there are some green and some white balls in a box. Okay, I'm not going to read this thing. You can read it yourself because we're running out of time. So what happens here is the following. You've got a box, and there are some green balls and some white balls. In the beginning, A, you got 3 green balls and 1 white ball. So this is what you got in question A. And I'll tell you what the actual question is. The A you got 3 green, and 1 white ball. Okay, so oh, all right. Now, what we do is the following. J, this person called J, he removes 2 balls from the box, right? Without looking. Now, if they are of different colors, he records this as a win. But if they are the same color, he records it as a loss, right? So it repeats this action a large number of times. Okay, so in the first case, you've got 3 green balls and 1 white ball are used in the game. Show that the probability of winning is the same as that of losing. Now we have to work out the probability. So you've got green balls. We have to identify. You call these G1, G2, and G3 because they are different. And then we'll call this white. I could have picked this ball, or picked that ball, or picked that ball. Although they've got the same color, but they are different balls. So let's see what are the possibilities. Let's list down all the possibilities that he takes when he takes 2 balls. So you could have picked G1 and G2, or you have picked G1 and G3, or you have picked G2 and G3. You could have picked 2 green balls. That takes care of all that. Or you could have picked 1 white ball, but then you'll have G1 and the white ball, G2 and the white ball, and G3 and the white ball. Now, according to this, they say if they are different colors, this is a win. So this is a win here, and this is a loss. But you can see the number of wins equals number of losses. So therefore, the probabilities of winning is the same as that of losing. Right? Number of wins equals number of losses. That's 3 each. Okay, so equal. The probabilities are the same. You have the same chances of winning or losing. Okay, so let's get on to the next part. The B part. Now it says 9 balls are used in this game, and J still has the equal probability of winning. So how many balls must be green and how many balls must be white? Okay, so what you have here is, again, you got your box here, and you got 9 altogether. The 9 are used in the game, but they don't tell you how many green and how many white. So suppose I say n green. And that will be 9 minus n white, because there are 9 balls altogether. Okay. Now what is the probability of winning in a case like this? And you want to know, oh yeah, you know that the probability of winning is the same as that of losing. So we'll have to work out the probability of winning, which is the same as the probability of losing. So you got 9 altogether. So the total number of, let's do that first, total number of ways of choosing 2 balls from 9. See, to go back to this, the total number of ways of choosing 2 balls from 4. Now, there's a formula for this. In general, if you if you want to pick 2 objects from n objects, then it's always the number of ways of doing it is n into n minus 1 over 2. And this is an important fact which all Olympiad students should know. The number of ways of selecting 2 objects from n objects is n into n minus 1 over 2. So here I needed to pick 2 balls from 4. So the total number of ways is 4 times 3 divided by 2, because 4 times the 1 less, and 12 over 2 is 6. And you can see I've got 6 here, right? So here, the number of ways here will be 9 times 8 over 2, and that gives you 36. Right, so that's the total number. So that goes in the denominator if you want to work out the probability, right? So that goes into the denominator. Now we want to know what are the successes. In other words, I want to, the probability of winning is the same as the probability of losing. So I've got a half is equal to, now I want to find out in how many ways can I choose maybe 2 equal balls, two equal colors. All right, so I want to choose 2 green. So how many ways can I choose 2 green from n greens? There it is n into n minus 1 over 2. This is choosing 2 greens from n greens. Now you want to choose 2 whites from n minus 1. So this gives you all the pairs like this, 2 greens, right? And these, we're counting the losses, right? I think the loss is, if they are different colors, it's a win. So yeah, so if they're the same color, it's a loss. So we're counting the losses. And I want to now choose 2 whites from n minus n, 9 minus n whites. So it's 9 minus n. You subtract 1 from that, you get 8 minus n over 2, right? Because the formula is n into n minus 1 over 2. Okay, so there it is. I've got an equation involving n, and we have to calculate that. 36 over 2 is 18, and that's the numerator. Let me multiply that by 2, and that gives you n into n minus 1 plus 9 minus n into 8 minus n. Okay, and now you can work this thing out. Let's see, you get 36. Here is n squared minus n. And when you expand all this, you get 9 times 8 is 72 minus 17n plus n squared. And then if you bring all the n squared to one side, okay, it's a n squared plus n squared is 2n squared. Take that out. Minus 17n minus n is minus 18n. And 72 minus 36 is 36. And that's equal to 0. And you have n squared minus 9n minus 18 equal to, no, it's 72. 72 minus 36 is plus 36. All right. And yeah, so this actually factorizes. This factorizes. This is n minus 3 into n minus 6 equals 0. So n is 3 or 6. So the number of green balls is either 3 or 6. So it asks you, how many balls must be green and how many must be white? So the answer is, the number of green balls is either 3 or 6, right? And of course, in that case, the number of white balls will be 6 or 3. So that's the answer to that question. Now, the last question here says, prove that if an equal number of green balls and white balls are used, now, that means the number of green balls here in C They both are green. I mean, both are, the number is the same. So you got n green and you got n white. So this time, this numerator now that becomes very similar. It will be n times n minus 1 over 2 plus, you got the same number here. So it's n into n minus 1 over 2. Right? And if it's equal to half, you're going to get that this is equal to, again, 18. 36 over 2 is 18. So this thing here will lead to this because the number of green balls is the same as the number of white balls. And when you work this out, you get n into n minus 1. Yeah, but it's not 36 anymore. Sorry. Because the total number, you got 2 n balls here now. So you want to choose 2 balls from 2 n balls. And how many ways can you do that? So at the bottom, you got 2n times 2n minus 1 over 2. Right? And so this will be the probability. Now you want to know whether this is actually equal to a half. Right? And when you work this thing out, you see that it's impossible. Let me say why. So there's no value of n which will make this, sorry, this equation looks rather complicated because you're taking fractions. So the 2's cancel. And in fact, even the n's cancel. There's an n. Okay, these two are the same. So you have, these two are the same here. So you're adding this to itself. So it's twice this, and the 2's cancel. So the numerator is that. The bottom, you got n over 2n minus 1. Right? The 2's cancelled there. And you want to know whether this is equal to a half. The n's cancel. Right? So you have n minus 2n minus 2. 2n minus 2 equals 2n minus 1. Now look at this. That means 2 is equal to 1. This is impossible. So therefore, if you assume that you can have half, you get an impossible situation. So you can never get equal probability. The question says the probability of winning can never be the same as that of losing. Right? That means the probability can never be half. Okay, so that takes care of number 14. And then finally, this is a long, drawn-out thing. So let's get on to the last problem. But as usual, yeah, you got this thing all worked out in detail here. So in case you didn't understand what I said, I'm showing you the screen, and you can go back and freeze it and watch what's happening there. So let's now get to the last 15th problem, 15th and the last problem. And what does this say? Okay, I'm not going to read all this long thing. You got rooks here. A rook is sometimes called a castle, and this is a chessboard. Now, these rooks are not behaving in the usual way. I'll tell you why. What's happening here is that you want this, you got a black rook and you got a white rook. Oh, actually, they need not be the same, but we can assume this one is black and one is white. But you got these two rooks which are placed like this. See, given the starting positions below, with player A to make the first move. So the rooks are placed here. A, there are two people who are playing. A places his rook here, and the opponent places his rook here. Right, now they start. Now A makes the first move. Now these rooks, once A makes a move, it says here that, I'll just read this thing. They can move horizontally or vertical, and each cannot move into or over the line of attack of the other. Now, this cannot move. Like, for instance, I can't move. This is the other one. I can't move beyond this line here, and I can't move beyond this line here. Right? So I must go as far as I can, but I can only move horizontally or vertically. So what happens now is that, so once I come up to a certain position, then it's B's turn now. Now B also cannot move. The same thing happens. They can't move across the boundary lines created by A. Like, for instance, in this case here, B cannot move anywhere here. Even here, you can't move. You can only move up to this point. And this is the boundary line on this side. You can only move up to this point. So this way, A can keep pushing B until he gets to the corner. And if B is here and if A is here, that means B cannot move any further. So the game ends at that spot. So the question now is, how many, given this starting position, right, what is the maximum number of moves that the game can last, assuming that each player plays optimally? In other words, each player plays as best as he possibly can. All right, so in this diagram here, I think what I can see is you try to push B into a corner, so you come down here as far as you possibly can, and this is the first move. Call that move one that A makes. Right. Then B, right, he doesn't want to be pushed into the corner. So what he does is he moves away from the corner. So he moves into that. He moves into that position. Now A, so it seems to me that you can't do that. Yeah, if he moves here, then he's got a problem, because then A doesn't have a move now. I think A will have to move here. Then B moves here. That's the second move. And then A moves into this position. Now B is forced to move away now. So B moves into this position here. And A, the fourth, this is the fourth move. And the fifth move is here. And he keeps pushing him into the corner. Right? And you want to know how many moves are there altogether. Okay, so I've got the scenario here. We'll work this thing out. You see, I made the mistake of A, the first move. This is A1. It has to be here. It can't be here, because B will move there, and then B will start forcing A. So you want A to win. So he has to move in there. So now B, he can either move there, he wants to get away, or there, right? Suppose he decides to move there, then A forces him, he moves here. Then B is forced to move here. A squeezes him, you see? Comes down here until he comes to this, and then B comes down, A comes down, B comes down. So you can see how many moves there are altogether. B makes 6 moves. B makes 6 moves, and A makes 7 moves. So altogether there are 13 moves in this problem. So this long question here, it says in this particular position where A and B are, and then so the maximum number of moves is 13. It's a maximum because B plays optimally, right? It tries to prevent him from squeezing him into the corner. Now, is there a winning strategy for player A? As we said, you play A the way we did, and is a winning strategy for player B. So B doesn't have a winning strategy, but I think the starting points can make a difference. I think if A and B are right next to each other, like for instance, suppose A and B are next to each other in the beginning, right? And if A moves first, then A will lose. So which player can always force a win, and how can this be done? But I think they are referring to this particular position here. But there is, in this particular position, it says, given the starting positions below, A will always win, right? A will always force a win, as we saw. Okay, so that brings to a close this rather long session. And thank you very much for listening. We want to close this, which is the Junior Round 3 2023, which was quite a tough competition. All right, so let's stop there.